In this presentation, I will introduce a solution to integrate multiple application security tools into Jenkins using a single generic pipeline control with a JSON configuration file. The basic idea of this solution is to provide an easy way to automatically onboard projects, analyze them with different set of tools, and then get back into Jenkins builds the security status of those analysis. The design of this solution is meant to address large organization deployment issues when it comes to implementing an application security program. The issues I focus on specifically are related to scalability, standardization, and maintainability. Starting with scalability, what I would like to have is a means to minimize your effort to onboard new projects, as well as the level of knowledge on the technical features of the underlying platform. Ideally, I would like the solution to configure itself for a new project just by specifying where the code can be found and the profile describing at high level what is the application made of and what are the security expectations. Then, based on these specifications, the solution would select which analysis to run and using the tools that are available with the appropriate configurations as specified by a security team for this type of profile. Well, actually, even most of the relevant profile specification can be guessed from the code using tools such as Microsoft Application Inspector, which provide an inventory of the artifacts in the code repository, all of them classified against some predefined domains. At least this is what I'm being investigating on this topic. But such a profile is not a pipeline. As compared to a usual pipeline or job description in continuous integration, the profile I'm talking about describes what is the application and expectation as opposed to how to build, to scan, or to relate to the tips and tricks of the audit. The key point here is that onboarding a project this way is about a dozen of lines of the configuration file. Most of them can be guessed from the repository content. This allows an application manager or a security auditor to see the platform as a whole and not as an aggregation of scanning tools. So now let's assume that we are indeed able to provide an easy path to onboard all or most of the project in the program this way. The next issue we quickly have to address is how to scale our scanning and audit capabilities. And it's not only about sending in the cloud computations, relying on on-demand resources. It's also about how to handle a massive amount of data to be generated by such a level of automation on the long run. And this also goes by automation. Anyway, regarding the computational scalability, I relied on the Jenkins agents, which already supports adding dynamically new resources and even ephemeral ones triggered from Kubernetes clusters. I created for that purpose a set of Docker containers for managing the agent and also the different stages of the generic pipeline, and especially for the build phase. With respect to the audit scalability, the key point here is not to expose the findings generated during the analysis. What is relevant is a view of the policy violations generated from the findings when automatically analyzed. In this demo, I just limited myself to a small report from a set of rules, counting the number of findings along few categories. It's definitely not enough, but it illustrates the basic idea, which is not listing the findings, but listing the policy rules violations. And to be able to build the automation to manage those data, we also need to enforce standardizations in a way projects are created and maintained across each of the tools of the platform. Again, it's a matter of working in a consistent way across projects and providing a wrapper around the platform for implementing the standardization constraints on each of these tools. Achieving that level of abstraction on the top of the platform's tools will dramatically ease the job of the tools administrator, as we could enforce best practices in the way those tools are used. We could expect that those best practices will address most of the issues, such as the database bloats, for example, we already know to be the root causes of the large number of customer support engagements. The last benefit I will expect from a multi-platform is related to the maintainability. As we consider that a large number of projects will be onboarded, we need to design the solution with a consistent process for fixing and upgrading capabilities and features. The kind of characteristic I expect is that adding a new feature won't break anything on any existing project. For example, updating a policy compliance rule will automatically apply to all the projects to which those rules are relevant. And upgrading a platform or a tool in the platform should also be seamless. I also tested while I did the support for Sonar that adding a new scanning tools can also be done seamlessly on all the onboarded projects which automatically benefit from it. Basically, maintaining the platform of the solution won't require project owner to update their own configuration.